What is even happening here? What is all of this? That's what we're going to talk about in this one. This is Saccorhytus. Saccorhytus. There's a little mascot, and it is a Saccorhytus. And these are all the same thing, shown from different views and in different reconstructions from a little earlier or later. And yeah, there's something else, aren't they? Let's go learn a little more about these guys. So, Saccharitis are really early. So these are from the very early Cambrian in China. And so these may fall into that gap between the bottom of the Cambrian and the Chengjiang preservation. So these are potentially, something that is very early and a very early evidence along the path for one or more of these developmental pathways that we later see. So look at it. I think the compelling thing is that it kind of looks like a face with little eyes and a little nose and a little mouth. The eyes and nose are probably not the eyes and nose. The mouth probably is a mouth. And what you'll see there are, it looks as though it's got like a little ring of plates around the outside, like a little monster mouth like that. And it actually looks like it has multiple rings of plates around the outside. That sounds kind of like a tardigrade mouth or like a lobopodian mouth. So it's sharing some of the same characteristics we would see there. Although those are both animals with a gut, so a tube that passes through them and comes out on the other end and has an anus. And these are not. These have a mouth and very little else. And you can actually see the mouth in different degrees of being open in the different fossils. They're all fossilized just a little bit differently, but they sort of get squished down like that. And so here you can see one of them where most of the little oral spines have kind of fallen out, but you can see the mouth that is open there as a little piece of something that's inside. Probably from where it was fossilized. So yeah, these are very early animals from China. They were originally interpreted as being on the way to becoming chordates. So right beside chordates, you have vetulicolians and vetulicystids. And these are, here's our vetulicolia. We have some fossils of these. We'll be able to look at those. These are subject of some argument. There are papers out there that say that these have a lot in common with chordates. Everybody seems to agree that they are at least deuterostomes, which are a group of animals that are going to include the chordates, like us, and things like the crinoids and echinoids, echinodermata. And so that was the original position of these based on a morphology-based phylogeny. But when you look at that, deciding what you're going to call the different parts and how you're going to rank them will have a very big influence on where this thing appears on your tree. Because if you say this is a mouth, then you mark it as yes, having a mouth. But if you call this the anus, then where is the mouth? Yeah. Is it a filter feeder? Is it a predator? It's hard to say. What are these little things up here? These little chimney looking things? Yeah. Depending on what you do with those, is it a sensory structure? That was one of the original propositions. Or is this something else? Is this a little pore that could let water in or out, possibly? Is this the hidden anus? Does it have lots of anuses all over its body? Looking like barnacles? Yeah. Fascinating. Anyway. Then, more recently, after the original publication, some people went back there and they got a whole bunch more of these specimens. And they found that everywhere that you see a looks like a broken off little thing like that, actually you can find others where there's a great big long spike that is attached there. And so these are just the bases of a spike that is broken loose. And so originally the spikes were just entirely closed. They were like little horns. So, oh, that doesn't look like it. They found some where you can actually, where it's broken open, like the back of it fell off and you can actually see through to inside. And this mouth-like tissue here is nicely sort of folded over, crenulated, yeah, almost pleated. But you can see it from the back right here. So looking into this thing, all the features that we can see are literally embedded in the multi-layered, here's the inner layer and here's the outer layer, the multi-layered body. And having a two-layered body means that you can retain an inner layer while shedding your outer layer in order to grow, which that doesn't sound like you and me, does it? Yeah, that sounds like an ecdysozoan. It sounds like something closer to arthropods than it is to people or starfish. And that is the new interpretation. These are the little mouth-like structures that occur around this presumed mouth, this opening. I think they do still agree on that. And they had little prongs on them as well. So fantastic. Yeah. Here is lateral protuberance. And here you can see on a lot of them it is broken out, but on just a few you can see one, and it's actually filled in. It's got another plate on the inside of that should be there. And if that sort of inner plate, which is making the cone shape, if that gets damaged, then you end up with a little hollow just like that. And you just have the outer plate that was around it that's there. And so, yeah, the new interpretation is that this is probably not at all a chordate or on the way to being a chordate or a deuterostome of any kind. It's probably an ecdysozoan, stem group ecdysozoan. Although, as the authors of the new paper and the old paper, to be fair, pointed out, it's really hard to put something as strange as this and tiny as this onto a tree. They have a bunch of these at this developmental stage, so this may be what adulthood looked like. Just given that if you take a scoop of people, you'll find that most of them are big, and that's not because people are only big, but it's because we grow to a certain size and then we stop growing. And so for most of our lives, we are, about that big. Yeah. You, me, everybody. So on their giant tree, which has fairly good stats for these trees, they actually show that Saccorhytus is the best fit. I think it's 96 or 98%. There you go, 98% branch support. Yeah. As clustering with the ecdysozoans as a sort of a primitive thing that is, loosely affiliated with arthropods and things like arthropods, but also loosely affiliated with other skin-shedding organisms like nematodes and chinorhynchs and loriciferans, all those cool things you would have learned about in invertebrate biology. But not on the branch that leads to brachiopods and things like that. So there you go. And yeah, so there you go. That's a Saccorhytus. And it's just the most fascinating little creature. Let's just, take a minute and look at that. Marvelous. But that's the evidence. It has a multi-layered covering. Nothing on the inside has ever been preserved as far as anyone can tell. And it appears to be a very primitive ecdysozoan, but either before the development of the anus or this is a group that just didn't have it for some reason. It may have just sort of taken in food and expelled waste from the same chamber. Flatworms, for example, do that. And they're doing just fine. There's so many of those. So, yeah, it's not necessarily an unsuccessful strategy. But yeah, all the things that we thought were holes turn out to be awesome giant spines. They kind of missed these three that are sitting over the mouth. They've got it reoriented. These little bands running here are now down here. They think that makes a little more sense. And there you go, little stem group ecdysozoan. All right. Thanks very much. Saccorhytus. 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 Yeah, remember that name. Yeah. and remember what it is. Thanks.